Hello, and welcome to Golden Droplets, a series of webinars intended to narrow the distance between the academy and the industry. In today's episode, I will start talking about some parts of my book, Systematics of the Magmatic Processes. Specifically, we are going to be talking today on how to describe plutons and volcanic formations. So, once again, Golden Droplets, episode number 49. Enjoy.
Main steps when studying a pluton.
The term pluton is used here in a general sense, implying a typically intrusive subjacent magmatic body, large enough to be mapped to scale. A pluton may consist of one or more rock units, while the same is true for nearby plutons also. There are three main steps in the study of a pluton. Step 1. Study of each individual magmatic unit, its mineralogical characteristics, and their relationships with other units. This is usually accomplished by constructing several geological cuts along individual magmatic units. Step 2. Accomplish a series of geological itineraries transversal and perpendicular to all the structures. In areas of low exposure, the appropriated number of trenches and/or mapping drilling should be done. Main objectives of study at this stage are to study the form and contacts of the magmatic bodies and the determination of the different facies of the event. Step 3 will include more detailed study of the magmatic bodies and their effect on the host rocks. We should establish the internal composition of the magmatic body, study the contact zone and the mineralogical areolas that the magmatic body provoked in the host rock, as well as those provoked by the host rock in the magmatic body. Also, hydrothermal metasomatic alterations and the tectonic effects of the intrusion of the magmatic body should be studied in detail since mineralization is related and controlled by these processes. When identifying each rock type and studying their mineralogical composition, you may use the different tables and flow charts included in this book. Trusova and Chernov in 1982 recommend the following sequence on the description of the mineral composition of each igneous rock. 1. Start by classifying all the minerals in the rock in three groups: main, secondary, and accessory. 2. Estimate the quantitative amount of each mineral in the rock. 3. Describe each mineral, starting with the main ones. Usually, you should start with plagioclases if they are present. If any of the main minerals are altered, the description of those secondary minerals should follow the description of the main one. For example, if the rock has olivine altered to talc, after describing the olivine, you should describe the result of its alteration talc. 4. Pay attention to the relationship between crystals. This will help you establish the sequence of crystallization of the rock. Generally, this is easier to do on a thin section. It is strongly recommended to make several sketches or pictures of the relationship between the crystals. I strongly recommend the use of a portable microscope, like the Dino-Lite model. 5. Study the structure and texture of the rock and finally, determine the rock type and name. Contacts between plutons and host rocks are usually distinct and easy to map. Sharp contact may be irregular due to blocky reentrance, cuspate forms, or folds. These variations should be mapped to scale if possible or recorded in your notes. Contacts are usually marked by a chilled zone, but they also may be schistose or melanitic if the magmatic body was placed diaperically, after the body was almost completely crystallized. When the contact is a broad transition, the contact line is generally placed at the center of the gradation zone. Dikes near the contact of plutons with the country rocks are useful to determine the relative age of the magmatic event and may give some indications of the composition of the first magma, for example when the dike is associated to the pluton, but cut by it. Dikes without chilled margins will indicate a syngenetic formation of both events, while dikes with chilled margins will indicate that the dike was placed in the pluton after it had cooled. Usually, younger units show a broad gradation away from the contact, involving one or more color, grain size, mineral content, number of inclusions, and abundance of schlieren. The emplacement of a younger unit will typically remove the original marginal facies of the older, which will therefore be more uniform than the younger. Of course, the most exact way to determine the age of a pluton is by using the potassium-argon, the uranium-lead, or the rubidium-strontium methods. Another important moment is the determination of the different facies of the studied body. Facies is a group of rocks formed from the same magmatic batch, but in different conditions. This will provoke differences between their textures and compositions. Usually, we define 4 main facies. 1. Satellite. 2. Endocontact. 3. Exocontact. 4. Core. Finally, special attention should be directed to the study of the vein systems in association with the hydrothermal metasomatic and tectonic alteration of the rocks.
Main steps when studying a volcanic formation.
Volcanic formations are very complex. From one end, they have many things in common with sedimentary rocks, while from the other end they have also many characteristics in common with igneous intrusive rocks. So, when studying them, the geologist needs to keep in mind this dual condition. According to their depth of formation, volcanic rocks are classified in 4 main groups. 1. Effusive, when lava reached the surface. 2. Volcanic fragmental, as the result of explosive volcanism. 3. Neck, lavas that fill conductive channels in volcanoes of central and fracture types. 4. Subvolcanic, lavas that are formed in near-surface conditions, while they were moving toward the surface. As with the intrusive igneous rocks, it is very important to determine the facies of the volcanic events. Table 2.1 shows the main volcanic facies usually determined during geological surveys. Among the most important steps of the study of volcanic rocks, we have the study of their mineralogical composition in general, and of their phenocryst assemblage. I recommend you use the following sequence when studying the mineral composition of the volcanic rocks. 1. Start by determine the texture of the rock using the Igneous Rock Texture Identifier copyright flowchart from this book. 2. If your rock is porphyritic, start by describing the mineral composition of the phenocryst assemblage. The following points should be studied. A. Estimate the number of phenocrysts compared to the total volume of the rock. B. Determine the composition of the phenocryst of the ground mass. The following aspects should be taken into consideration. A. Composition of the microlites, crystals, and their quantitative proportion, so we can determine the color index of the rock. B. Determination of the mineral composition of the ground mass, and the number of the plagioclase present. C. Establish the quantitative relation between microlites and volcanic glass. D. Texture of the ground mass. 4. Finally, determine the name of the rock, its texture in general, and the texture of its ground mass. The porphyritic texture is commonly explained as the result of a period of slow cooling during which the phenocrysts grew, followed by a period of rapid cooling or quenching stage, during which the ground mass is formed. It is logical to assume then that the ground mass will represent the composition of the lava during its effusion, while the phenocrysts will represent the composition of the lava. At greater departments, crystals growing at this early stage are known as intratelluric and are of great importance in the geological interpretation of the volcanic rocks. When determining the modal composition of the phenocrysts in a thin section, a mechanical stage, and a point counter should be used. During your determinations, avoid strongly zoned crystal margins formed by enlargement of the crystals during the quenching stage. During the study of the phenocrysts, you should remember that your rock could have undergone weathering or other kind of alterations, and the minerals have been transformed to other less common minerals. Refer to the microscopic descriptions of each rock that you will fit in this book, to help you identify these alterations. Finally, the study of the structures of the volcanic units is an important step in the geological interpretation of the volcanic process, and structures as pillow lavas, lava floods, and others should be
We are about to study? If so, you can buy the book Systematics of the Magmatic Processes, a practical approach to the study of petrological data from Amazon following this link https://buff.ly/30newNXS. See you in the next Golden Droplets episode.
I think these videos are brilliant. and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.